Good evening. How are you, students? I hope all are good. Take care of your health and enjoy your holidays. Eat healthy foods and stay healthy. Obey your parents. And one more good news. So you all are promoted to 8th standard. Online classes have been started for you. So pay the first term fees and get the books soon. So this is your 8th standard book, term 1 book. So students, this is your, for this term you are having totally 8 lessons. The first 3 lessons will be physics, and next 2 lessons for chemistry, and last 3 lessons is biology part. So first we will move on to the lesson. We will move on to our lesson, measurement. So already you have studied this one in your 6th and 7th standard. So lot of introductions have been given for this lesson. So once again we will recall all the points. So once again we will recall all the points what you have studied earlier in your 7th standard. So first thing, measurement. So this one is a physics part, no? So what is meant by physics? It is a measuring and recording data of utmost importance. So what it is given here, it is what is meant by physics, measuring and recording data. A set of values will be given and you have to record the data. Otherwise measuring means, so using the equipments, that is physical balance or otherwise spring balance, you have to measure the objects, given objects. So that is what it is given here. And once again, next one is measurement. Measurement means what? Measurement is a method to obtain information regarding the physical values of variables such as pressure, temperature, mass, length, etc. So what is meant by measurement? So you are recording, you are obtaining information from the variables. So what are all the variables? Pressure, temperature, mass, length. So this will give some information about what kind of temperature is prevailing in certain area. What mass it has. Mass means what I said. It is weight of an object. What is length? Length you will express in meters. What is the unit to express length? It is expressed in meters. Physical quantities like temperature, time and speed of a vehicle can be measured using a thermometer, watch clock, speedometer respectively. So what do you understand from these lines? So temperature, it would be measured using a thermometer. For example, if you are having fever and you are going to the doctor, what the doctor will do? He will measure the body temperature using a thermometer. But nowadays what we are using, digital thermometers are in use. And time, it would be measured using watch clocks. And speed of a vehicle, it would be measured using a speedometer. How fast the vehicle is traveling, that would be measured using a speedometer. In 1971, International System of Units with the international abbreviation SI introduced a uniform system of units to be practiced throughout the world. So what the scientists did in 1971, in order to maintain a uniform system of units, what are all that? Length, mass, time, for all this we have to maintain a uniform system of units. So for this 1971 International System of Units was introduced. So there are some basic rules to follow while expressing a physical quantity following the SI system. So you will read this one in your higher classes. For the next one is physical quantities are of 2 types. What are they? Fundamental and derived quantities. Fundamental and derived quantities. So what I said, physical quantities, it is classified into 2 types. One is fundamental quantities and another one is derived quantities. Now I will show you this 7th standard book. Once again we will recall what is meant by fundamental quantities and derived quantities. So what is meant by fundamental quantity? That cannot be physical quantities, that cannot be expressed in terms of any other quantities are called as what? Fundamental quantities. What are the examples we have seen for fundamental quantities? Length, mass, time and then volume. So all this we have seen for the fundamental quantities, isn't it? Okay. And next, length, mass and time I have said for fundamental quantities, no. And next one you are going to see is derived quantity. Physical quantity that can be expressed by the multiplication or division of fundamental quantities are called derived quantities. So what are all the examples for derived quantities? Area, volume, density and speed. So what is the formula to calculate the area? Length into breadth. And what is the unit to represent area? Meter. That is square meter means meter square, m into m. Meter square. Volume is length into breadth into height. That we will express in cubic meter or otherwise in meter cube. Density is equal to, what is the formula to calculate the density? Mass by volume. Mass means it would be represented in kilogram. Volume, it would be represented in cubic meter. So what will be the unit for this? Kilogram is kg and for cubic meter it is meter cube, or otherwise it could be written as kilogram meter to the power of -3. And finally, speed is equal to, what is the formula for that? Distance travelled by time taken. Distance travelled by time taken. So distance travelled is measured in meter and time is measured in second. So for that unit is meter, representation is m, and second s, or otherwise it could be written as meter second to the power of -1. So once again we will come back to our 8th standard book. The most fundamental quantities measured were mass, length and time. What is the fundamental quantities? Example we have seen mass, length and time. So they have for this they have a recorded history. What is that one? So this one will be given as a fundamental units, mass, length and time. But in the 16th century the measurement of temperature, and in the 18th century the measurement of electric current were added by the international system of units. So in 16th century the measurement of temperature is added to the international system of units, and by 18th century measurement of electric current were added by the international system of units. More recently, the amount of substance and luminous intensity have been added in the international system of units. That is, this one is already these two substances, that is the amount of these two measurements, the amount of substance and luminous intensity, and this could also be added in the international system of units. Now a flow chart is given for you to understand how these physical quantities are categorized. It is categorized into derived physical. So students, see this flow chart: derived quantities, fundamental physical quantities and other quantities. So what are all the example for derived physical quantities? Area, volume, density, speed, force. Fundamental physical quantities, what we have seen: length, mass, time. So additionally in 16th century what we have seen, temperature is added to the international system of units, and by 18th century electric current is added, and two more also added to the international system of units. What we have seen: amount of substance and then luminous intensity. So this is categorized under fundamental physical quantities. And supplementary quantities, that is what it is given here as other quantities, that is called as, in other terms I can say it as supplementary quantities. What are they? One is plane angle and another one is solid angle. So these were classified as what? Supplementary quantities. So the unit for plane angle is radian and the unit for solid angle is steradian. So students, with this we will end up our session, and today homework for you is, we have seen the flow chart as a flow chart for physical quantities, no, that you can write it as a homework, and take a snapshot of your homework and send it to the HIFI app. Write it 2 times. That flow chart you have to write it 2 times. Thank you, Pa.